Hi, this is Shyamala Gauri, Assistant Professor in CSC Department from Rohini College of Engineering and Technology. Subject code CZS 355 Neural Networks and Deep Learning. Unit 2 Associative Memory and Unsupervised Learning Network. The topic covered in this presentation is an associative memory, its training algorithm and testing algorithm. An associative memory. An associative memory network can store a set of patterns as memories. When the associative memory is being presented with a key pattern, it responds by producing one of the stored patterns which closely resembles or relates to the key pattern. Thus, the recall is through association of the key pattern with the help of information memorized. These types of memories are also called as content addressable memories. The CAM can also be viewed as associating data to address, that is, for every data in the memory, there is a corresponding unique address. Also, it can be viewed as a data correlator. Here, input data is correlated with that of the stored data in the CAM. It should be noted that the stored patterns must be unique, that is, different patterns in each location. If the same pattern exists in more than one location in the CAM, then even though the correlation is correct, the address is noted to be ambiguous. Associative memory makes a parallel search within a stored data file. The concept behind this search is to output any one or all stored items which match the given search argument. Heb rule. Its algorithm is given below. Step 0. Set all the initial weights to 0. Step 1. For each training target input-output vector pairs S to T, perform steps 2 to 4. Step 2. Activate the input layer units to current training input. Step 3. Activate the output layer units to current target output. Step 4. Start the weight adjustment. Second rule, outer products rule. Outer products rule is a method for finding weights of an associative net. Here input is given as denoted as S and output is denoted as T. The outer product of two vectors is the product of the matrices. S is equal to S transpose and T is equal to T, that is between n by 1 matrix and 1 by m matrix. The transpose is to be taken for the input matrix. This weight matrix is same as the weight matrix obtained by Heb rule to store the pattern association S to T. For storing a set of associations S of P to T of P, where P is equal to 1 to P, the weight matrix is calculated and it is given below. Auto-associative memory training algorithm. For training, this network is using the Heb or delta learning rule. Step 1. Initialize all the weights to 0. Step 2. Perform steps 3 to 4 for each input vector. Step 3. Activate each input unit as follows. Xi is equal to Si, I is equal to 1 to n. Step 4. Activate each output unit as follows. Yj is equal to Sj, for which j is equal to 1 to n. Step 5. Adjust the weights as follows. Wij of new is equal to Wij of old plus Xiyj. The weight can also be determined from the Heb rule or outer products rule. W is equal to summation of P is equal to 1 to n S into T of P dot S of P. Auto-associative testing algorithm. Step 1. Set the weights obtained during training for Heb's rule. Step 2. Perform steps 3 to 5 for each input vector. Step 3. Set the activation function of the input units equal to that of the input vector. Step 4. Calculate the net input to each output unit j. Step 5. Apply the following activation function to calculate the output. Thank you.